Okay, so I told you to do, try to do this one. Um, I wanted to talk to you because I didn't know whether you're going to write your weights down as decimals or whether you were going to write your weights down the way they were given. It actually, if you're doing it by hand, it actually comes out to be the same either way. Because if you do the multiplication right here with a decimal, your x times your weight, your data point times the weight comes out to be 12.4. Over here, if you do 62 times 20, you get 1,240. But it's going to work out to be the same because while these numbers are bigger, the thing that you're dividing it by, remember you do this thing divided by this thing, those two extra zeros will cause that to come out to be 80.6. Over here, when you add these decimals up, you get a sum of 1. And so when you add these up, 80.6, and you divide it by 1, you get 80.6. That's your average. So it doesn't really matter. Some people, I would do it like this because I'm, an old algebra teacher, and these numbers right here are not working numbers. These are numbers that you talk about. You don't work with them. So I know, just it's been instilled in me that if I'm going to work with 20%, I have to rewrite it as a decimal. So this is the way I would do it, but this way will certainly work out okay. Now let's go look at what happens when you do it on StatCrunch. So I've already computed this one using the data compute expression. And so you see right here, I created that x times y column, and then I went ahead and created the average, the weighted average, and it came out to be 8.6. So it'll let you use the decimals, because remember what it does. It just is going to add these up, and it's going to divide it by, it's going to add these up and divide the sum of these by the sum of these, the same way we do it by hand. And it's going to work the same way over here. I've already done the x times y column, but if I go over here to the data, go to compute, go to expressions, tell I want to build an expression, and I want to do the sum. So I need to scroll down here until I get to sum. The sum. And I'm going to do the sum of the x times y, and I'm going to divide that by the sum of the weights, and it's the weight with the W, okay? And then I'm going to say, okay, I'm going to put that in, we're going to call it capital, and I'm trying to make it look different than this weighted average over here because I don't want the two to get confused. So I'm going to compute, and it came out to be 80.6. So again, this way, StatCrunch doesn't care. But look what happens if I go and do it the other way. StatCrunch, you go to Summary Stats, and you go to Grouped Bin Data. So if I do the grade and the weight, so I have to select the right one, grade with an X, put that in the bins, and the count is the weight, and the weight with the little W. If I do that until it to find the mean, it says okay, and it comes out to be 80.6. So it does this one fine. But when you try to do that same thing, if you use decimals, you go to Stats, and we go to Summary Stats, and we go to Grouped in Bin Data. Now if we try to use the grade and this weight, the weight when I use decimals, and I tell it to find the mean and I compute it, it says, nope, can't do it. Because remember, they're calling that weight, they're calling it a count. And it's not going to let you count in decimals, because if it's literally a count, you only count things as 1, 2, 3, 4, 5, not 0.1, 0.2, 0.3. So they're not going to let you do that. So you say okay, and then you go and you change that to whole numbers, and then tell it you want the mean. It'll compute it just fine. Okay. So just be careful about StatCrunch and that. It doesn't matter to me which way you get it, as long as you're able to get it. Okay. Now going over to this last page, I can't find my blank one, hang on. If I go over to this last page and we talk about finding the mean of a frequency distribution, remember this is the information that we would use to build a histogram. So if we were building a histogram, you know, this would be along my x-axis, and somewhere right here, wherever 8 was, if your data was 8 through 11, then you went inside this bin, okay? And this thing right here is telling me that I have 37 numbers in here that are either 8, 9, 10s, or 11s. There's 37 in there. Now the problem is I don't know whether there might be 37 8s, or there might be 35 8s and 1 11, or there might be well, it would be 35 8s and 2 11s, or it might be 39s and an 8 and a 10, or whatever. I'm trying to count to 37. I can't do it in my head. But anyway, are you following me? I don't know what those 37 numbers are, other than the fact that they're either an 8, 9, 10, or 11. And the same thing is true for this next one, this next bin that goes from 12 to 15. I know that there's 49 numbers in there, but I don't know, are they all 13s, or are there 10 12s, 10 13, 10 14s, 10 and then 19 15s? I don't know what the makeup is. So I think you get the picture. So what you have to do, all you can do right here is average the numbers that are in there. So you're going to say 8 plus 11 divided by, no, you just find the middle. So it's going to be 8 plus 11 divided by, I don't know. Let me see. Is it going to be, I'm trying to see real quick. Is it going to be, it might be the same thing. 8 plus 9 plus 10 plus 11, and we're going to divide that by 4, or is it going to be 8 plus 11, and then we're going to divide that by 2? Comes out to be the same. That's kind of what I thought. It was going to be the same, because you're going to find the middle. So since we don't know what the numbers are, we find the average of this group. So the average of this group is 9.5. I don't know what this one is, so I'm just going to do 12 plus 15 divided by 2, 13.5. So I bet this one is 17.5, and this one's 21.5, and that one's 25.5. So I found the average of these, and now I'm going to take the average and multiply it times the frequency. So I'm going to say the average times the frequency. So this becomes like your x. The average becomes your x, and we do x times the frequency, okay? And so you multiply those two together. I'm going to show you. I've already got it done. So you multiply 9.5 times 37, it comes out to be that, 13.5 times 49. And then you do the same thing. You find the sum of those, and you find the sum of these, and you divide it, okay? So if you're doing this on a frequency, if you're doing this on StatCrunch, you can do it the exact same way. We would put this number in one column and these numbers in one column, and then do it either method, okay? No, wait, I'm sorry. Put these numbers in one column and these numbers in one column, and then use either method. You can use the one where you compute the expression, and you'd create this this column right here, and then you would divide the sum of this by the sum of that. Or you can put this column in and put this column in, and then do what do we do? You do stat, and you do summary stats, and you do grouped bins. Okay, and then you would just use, whoops, why do I keep going there? I don't even know. This is where I'm trying to go. You could put this in a column, this in a column, and then do stat, summary, grouped bins. And then it'll compute. Either way, you'll get 17.5. Okay, I'm going to go ahead. I don't know how long I've been, but I am going to go ahead and tell you to look at these definitions. These are frequency distributions. This one right here is considered symmetric because the highest point is right in the middle, and then on the left side and on the right side, it gets smaller at the same rate. So it's symmetrical, okay? So the left side and the right side look identical. This one right here is what we called a uniform distribution. Uniform meaning it's the same all the way across. So we've got, I don't know how many bins here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bins. We've got 15 bins, and every single one of them has 20 things in it. I'm assuming that this is a frequency. It's not labeled right here, but anyway, so these all have the same number of items in the bin. This one right here is said to be skewed left, and the way that I tell the difference between being skewed left versus skewed right, there's two ways. One, the small part down here, this thing right here is called a tail. Is it, I don't know, is it T-A-L-E or T-A-I-L? Tail, that looks right, but I don't know. I think that's what it is. So this is the tail. The tail where it, and this side has a tail too. Okay, but the left tail is a lot longer, okay, than the right tail. So since you tell it's skewed by wherever the longest tail is. So the left tail is longer than the right tail, so this one's skewed left. And again, it's the same, this tail right here, the right tail is a little bit longer than the left tail, so this is skewed to the right. You can also tell whether it's skewed left or skewed right by paying attention to the median is going to be the middle, no matter what. Notice the median is the middle here, and they're telling you right here that when it's a normally distributed, your mean, median, and mode are all the same number. So your average looks like your average is 8, your median was 8, and your mode was 8. Okay, so they're all the same thing. And these two over here, this one doesn't have a mode because we don't have one that has more than the other, but the mean and the median are the exact same number. And over here, your median is in the middle, and here your median is in the middle. It's going to be the highest one. That's going to be your median because it's going to be the one in the middle. But here, notice that compared to the median, the mean is on the left. So if the mean is to the left of the median, let me say it again. If the mean is to the left of the median, it's skewed left. When the mean is to the right of the median, it's skewed right. So here, it looks like the median here, and I'm just guessing, it looks like the median is 10. Because here's 9, here's 11, so 10's right there. So that looks like that's the median. And then the mean is pointing at 9.5. If we had the data, we could actually compute it, and we could make the histogram, and then we could actually calculate what the mean and the median are. But here, it looks like if you just focus in, I know it's not a very good one, but remember, this is in your book. Okay, so you can go to your book. I don't know exactly what page it is, but guess what section it's in? Chapter 2, Section 3. Now over here, we still have the median. The median on this one looks like it's down here at 6. Okay, And then the mean looks like it is at 6.5. So here the median is smaller. If you're on a number line and you're smaller than something else, then you're to the left of it. If the mean is to the left, it's gonna be skewed left. Here the median was about 6, and it looks like the mean is 6.5. So the mean is to the right. It's on the right-hand side. It's a number that's bigger, so it's skewed right. So if you have a picture to look at, just look for the longest tail. If you don't have a picture and you're looking at data, then you can compare it this way. All right, that should be the end of section 3. Good luck with your homework. Let me see if I can stop this video.